Our universe is finely tuned to support life, almost as if it were designed with us in mind. This idea, known as the Anthropic principle, suggests that the universe's physical constants fall within a narrow range that allows for the existence of stars, planets, and life. Imagine it this way. If you were to adjust the force of gravity, the strength of electromagnetism, or any other fundamental force by even the smallest amount, the universe as we know it would be radically different. Stars wouldn't form, planets wouldn't exist, and life as we understand it would be impossible. This precision is what makes our universe seem so perfect. Let's break this down with a simple example. Take the force of gravity. If gravity were just a bit stronger, stars would burn out more quickly, collapsing into black holes or neutron stars before planets could form around them. If gravity were weaker, stars might never ignite, leaving a cold, dark universe devoid of light and warmth. Now, consider the electromagnetic force. It's responsible for holding atoms together. If this force were slightly weaker, atoms wouldn't form molecules. On the flip side, if it were stronger, chemical reactions would happen too rapidly, making the stable conditions needed for life impossible. Moving on, let's think about the balance between matter and antimatter at the universe's inception. We observe that our universe consists predominantly of matter, while antimatter is rare. Had there been an equal amount of both, they would have annihilated each other, leaving behind nothing but pure energy. Instead, the slight excess of matter allowed galaxies, stars, planets, and eventually life to form. This imbalance appears too precise to be mere coincidence. We can also look at the universe's expansion rate. If the universe had expanded too quickly after the Big Bang, matter would have dispersed too rapidly for galaxies and stars to form. Contrarily, if the expansion had been slower, gravitational forces would have caused the universe to collapse back in on itself. The rate of expansion we observe today allows for the formation of the complex structures we see in the universe, from galaxies to solar systems to planets. Now, how does all this fine-tuning come about? Scientists have proposed several theories to explain this cosmic conundrum. One prominent theory is the Multiverse Hypothesis, which suggests that our universe is just one of many, each with its own set of physical laws and constants. In this vast ensemble of universes, it's not surprising that at least one would have the perfect conditions for life. We happen to live in that lucky universe. Another explanation comes from the realm of string theory, which posits that the fundamental particles we observe are actually tiny vibrating strings. According to string theory, these strings can vibrate in many different ways, giving rise to different particles and forces. The specific vibrations that result in a life-permitting universe could be just one of countless possibilities, again hinting at a multiverse. Now, let's talk about cosmic inflation, a rapid expansion that occurred fractions of a second after the Big Bang. This theory helps explain the uniformity and flatness of the universe. Think of it as blowing up a balloon. As it expands, any irregularities on its surface smooth out. Inflation similarly stretched the universe, providing a uniform backdrop on which galaxies could form. Some argue that the fine-tuning we observe could be evidence of intelligent design. They suggest that the universe's perfect conditions for life point to a deliberate creator. This perspective often relies on philosophical and theological arguments rather than empirical evidence, and it remains a topic of intense debate. In closing, the concept of our finely tuned universe isn't just about physics and cosmology. It touches on profound philosophical and existential questions. Why do we find ourselves in a universe that seems so perfectly suited for our existence? Whether it's a result of sheer chance, a multiverse, or some form of intelligent design, the fine-tuning of our universe remains one of the greatest mysteries in science. To reflect on this further, consider how life itself is a series of fine-tuned processes. From DNA replication to the balance of ecosystems, life on Earth thrives within narrow parameters. Our universe exhibits this same kind of delicate balance on a cosmic scale. This remarkable precision continues to inspire awe and curiosity, driving scientists to explore deeper into the origins and nature of our existence. As research progresses, we may one day uncover more about why our universe is so perfect, shedding light on one of the most profound questions humanity has ever asked.